Hi everyone. We'll just wait for a couple of more minutes so that whoever is yet to join can join in the meantime. And soon, within a few seconds, we'll be going ahead and starting with the session. Let's just wait for a couple of more minutes. Hey, hi Chagan, hi Sharad. Hi to all those who joined us. Once again, good morning, good afternoon, and good evening to all those who have joined us in today's session. I'm your host, Anish Krishnan, Head of Marketing at 𝐶𝐶 Group. And in today's session, it's all about Spark Insights, Industrial AI Edge 2026, from connected assets to intelligent operations. To dig deep, we have our experts on this subject. I welcome Narayan Gokhale, Ignatius Daniel, Vaishak, and Akash, who will take us through the major shifts in 2025, the strategic priorities that manufacturing leaders should look out for, and of course, the predictions for 2026. With that, once again, I thank you all for joining us. And if you have any queries or questions, please drop us in the Q&A section below. And let's dig deep into the insights then. Over to you, Narayan, sir.
Thank you, Anish. Thank you for setting this up. And thank you, everyone who joined us. I'm sure more attendees will join as the webinar proceeds. So we are here to talk about Spark Insights Live, Industrial AI and Edge 2026, from connected assets to intelligent operations. We'll try and cover this subject in roughly about 50 to 55 minutes, and we'll have 5 to 10 minutes for Q&A. And as Anish suggested, feel free to put in your questions in the Q&A box, and we'll try and answer them. And if there are more questions, maybe we'll kind of send it later on as an email response to you guys. Okay. So interesting topic for us here at 𝐶𝐶 Group, Industrial AI and Edge. So we'll be covering the entire industrial spectrum, the entire industrial landscape, starting from the core manufacturing operations, the energy and utilities that aid it, then the inbound and outbound logistics, and then the connections with the supply chain, and then downstream onto the customer engagement systems. So this is all the industrial spectrum that is where industrial AI is playing role. Of course, we'll try and focus more on the core manufacturing operations for sake of focus. And then the next part is about the edge, because that's the infrastructure from edge to cloud, where industrial AI is playing more and more role, as we'll see as a part of this particular webinar. And by edge, we mean right from constrained edge devices to smart edge devices to on-prem edge to service providers edge, right up to the data center edge. So we'll kind of have this entire spectrum where industrial AI is playing role. And how are the connected assets? Now, by assets, we mean manufacturing assets, energy assets, utility assets, mobility assets, and most importantly, the process assets within the company and the human assets. So all these were used to work in silos as independent entities, and now they're from getting connected in all respects. The technology that is getting connected in the assets, and the people and processes are also getting connected, and how it is leading to intelligent operations. So that is the kind of scope I'm laying out for us. And me and my team have laid out these insights. And of course, I would want my set of analysts to actually come in and share what they have to say. And they're very excited to share about what they have seen and what they would like to, and what they're predicting to see in 2026. So let's move on to the next slide, where some of you who may not be very aware about Spark Matrix, and with the title of this particular webinar is Spark Insights Live. So we just thought we'll quickly touch upon this flagship product of ours, which is Spark Matrix, which stands for Strategic Performance Assessment and Ranking, which is a competitive benchmarking tool, which is where we kind of rate vendors for technology excellence and customer impact. And they fall under the categories as you see on the screen: Spark leaders, strong contenders, and aspirants. We are not going to spend much time, but so this is the main research that we do in 𝐶𝐶, and all our insights are kind of drawn based on this. Now, moving on to the next slide. Now, what kind of research we do and what kind of platform software products that we rate as a part of Spark Matrix. This is the coverage as you see in the slide in front of you, connected operations coverage. So if you take the main operations piece, which is right in the center of the slide. So the entire, for example, if you take manufacturing operations, advanced planning and scheduling, the actual execution that happens through manufacturing execution systems, either discrete or process or hybrid, then the associated maintenance systems or asset management through CMMS, EAM, APM, and most importantly, the IoT platforms that connect all these assets. So these are the core, and nowadays all the operations have to be sustainable, climate friendly. So all the software platforms that have to do with energy transition, carbon management, carbon trading, that is also we cover. And as I just mentioned, Edge, a very important piece in industrial edge, which is Edge IoT analytics, edge management and orchestration, hyperconverged edge, Kubernetes for edge. So with this core operations, of course, there is an engineering and design piece that goes along with, right from computer aided and design to PLM, discrete and process, and right up to aftermarket services, which is field services, augmented reality platforms, connected frontline platforms, where I just said the human assets are getting connected through this. And the most important piece, as also you will talk as the part of owner, is the OT cybersecurity, the operations technology. And so we cover this entire subjects as a part of our research, and we are very glad to kind of provide insights as a part of this particular webinar. Let's move to the next slide. Okay, the way in which we have broken this into 4 parts, we'll start with 2025 in the review. What we have seen based on our discussions with end users, with system integrators, and of course the technology vendors, what is really working, what is not working, are any initiatives stalled, and are there any limitations? And then how are the ecosystems shifting? Because we're talking about connected assets and connected operations, which is nothing but an ecosystem by itself. So what's happening there? How are we seeing unified data models, interfaces? And then what would be the strategic priorities for end users, having taken a look at what's happening and what are the shifts taking place? So that we will cover in the 3rd section, and then stay tuned for the most exciting part, which is the predictions for 2026. I hope that kind of sets the stage for our deep diving of what we want to present. And so let's to the next slide. Let's go into details with 2025 in review. So 2025 in review, our team will present, like, when interacting with end users, what is it that we found? Okay. And we just took one example, like, for example, edge AI is proving out to be a very important component of overall industrial AI. So what do successful edge employments look like? And how is this connected industrial operations journey? How have we reached so far? And what was this particular year of transformation? Were there any reality checks? Which were the select pockets where AI made an impact? And while doing so, what were the hurdles? What were the gaps? And how were those gaps bridged? And what were the key lessons learned? So we are excited to kind of present, my team is excited to present what happened in 2025. One more perspective I have to add, especially when you're talking about year 2025. Last month, November 2025, was exactly 3 years when generative AI came big time through launch of ChatGPT in November 2022. And lot has happened in past 3 years. AI has suddenly become the most important talked about point in entire technology landscape. The consumers adopted it first, the enterprises and governments adopted, and later on industries also adopted, because industrial AI is slightly different from a typical consumer AI. It's more use case based. So we'll bring out those perspectives also as we go along. So therefore 2025 was really a year, as you will see, where industrial AI started becoming mainstream in the industrial landscape. So who wants to jump in with what end users are saying?
Hey Narayan, I would like to step in. So hey Narayan, thank you for this wonderful start that you have given us. And hello my fellow attendees. So we start off with what the end users have been communicating with us in the year 2025. We have a lot of insights gathered around, so we try to bucket it around 3 different segments, and we like to give you overall gist about. So starting off with, I would like to go deeper and bring you the actual voice of the customers, what they're trying to say. So starting off with, AI is no longer a nice to have, and it's more like a control layer now. The end users wanted to have more control of the IT and the OT space, where they can build and deploy assets that are more advanced and more capable of handling tasks on their own, more like an autonomous thing. And we also seen many enterprises as well as CRM and ERP vendors have already implemented AI to drastically improve their processes. And we also seeing that it's been extended into other industrial software space, whether it could be an MES or an industrial IoT platform or an APM market, so on and so forth. And we'll also be dealing with it in a much more deeper aspect in the subsequent slides as well. And we like to narrow it down at the same time. Buyers are now asking for a more domain-specific agents that understand their world. It's not more horizontal, it's more verticalized. They wanted to have decisions that are directly impact their revenue, cost, as well as they wanted to implement the data that is associated with their domain. And moving forward, they also wanted to have a proper data personalization, a context that will help their maintenance or their engineers or their domain in a subsequent way that yields more results as ROI or as well as in terms of cost. So, and I would like to welcome my fellow colleague Vaishak to share more insights on this as well.
Yeah, thanks, Daniel. So, hello everyone. I'll be talking more about what end users are saying when it comes to implementing a modern data infrastructure in plants. So, when we asked end users what changed for them in 2025, the strongest theme we heard was around modernizing data architecture and infrastructure. And this shift is being driven by very practical and frontline needs. So first, edge computing saw more adoption, mainly driven by the need for real-time operations and business reliability. So more processing is now moving closer to the data source to enable more real-time analytics. At the same time, there's a huge momentum behind cloud native and serverless platforms. So teams want infrastructure that scales automatically without the overhead of managing servers or turning clusters. We are also hearing a strong push towards data mesh and data fabric. So instead of one central team controlling all the data, organizations are moving to more of a domain-owned data as a product models with unified and governed assets. So we are we are seeing a strong demand for AI and agent-ready data platforms, systems where operators can just ask questions in natural language, automate analytics instantly, and trigger intelligent agents that can act on insights instead of just reporting them. Over to you, Akash.
Thanks, Vaishak and Danny. So while the excitement around agentic AI is real and it's undeniable, when I talk to end users about deploying this at scale, the conversation immediately shifts to operational excellence and trust. What we're hearing is that you cannot build a skyscraper on a swamp. Users are realizing that to have autonomous agents, they first need to have robust data ops and ML ops. They're asking for standardized pipelines because they need to automate the model lifecycle, deployment, monitoring, and all these things can't be manual anymore if you want speed. Secondly, there is a massive focus on governance and security as data moves from the edge to the cloud and then back to edge again, ensuring compliance like GDPR, HIPAA, and protection against sensitive IP. All these things matter so much more when it's AI, and it's the only way to maintain trust in these systems. And data observability, this has become the new non-negotiable. Users want deep visibility into data health and lineage. So for example, if an AI agent makes a decision, they want to know exactly what data drove that particular system to take that decision. And it helps them detect issues proactively before they disrupt existing production. So all these works, I say all this because all this works on the backbone of integration. We are increasingly hearing end users demanding solutions that integrate easily into their enterprise stack, and they want to remain open to shifting their business intelligence tool preferences. Yeah, Narayan sir, you have anything to add here?
Yeah, I think team, excellent compilation of what we heard from users, and as we talked about, like we already seeing agentic AI in terms of in ERP, agents for work orders, agent for accounts payables, same thing in CRM. So now we are seeing more and more that in terms of MES, exactly for recipes, for scheduling, for releasing of work orders. So as I said, from the enterprise world, it's coming very fast into the industrial world as well. And Akash, I can't agree more. Like AI rests on a solid data foundation. So I think end users, we are hearing the right signals from end users. So what's next that we are hearing in 2025? Next slide, please.
Yeah, so I think I will pitch in here. So basically, we were doing a survey on manufacturers who have implemented edge first architecture on their plants. So this is an ongoing survey, but since we are doing this webinar, I thought maybe let's share the statistics as of now. So when we look at the manufacturers who truly succeeded with edge AI in 2025, 5 benefits kept showing up. So the number one, cost saving. So companies save significantly by processing data at the edge rather than sending everything to the cloud, especially for video and sensor heavy operations. The second benefit, lower latency and real-time control. Because shifting real-time workloads to the edge delivered up to 80% latency reduction. This made robotics, visual quality inspection and safety systems far more reliable. And the third benefit was that predictive maintenance became a major success story. Now, among the companies we reviewed, we saw a 30 to 40% reduction in unplanned downtime and up to 30% lower maintenance cost. Now, the fourth one was plants using edge-enabled analytics improved significantly workflow visibility. They detected issues faster, reduced scrap, and optimized throughput, leading to more smoother and more efficient operations. Now, the fifth and probably one of the most important benefits that enterprises, especially those in the critical infrastructure domains, have achieved is greater reliability and data localizations. So we are seeing an increase in ransomware attacks on manufacturers, and edge deployments could seriously benefit those kinds of enterprise manufacturers. So overall, 2025 proved that when edge and AI are deployed correctly, the impact is real: a lower cost, faster decisions, and higher uptime. So team, you want to pitch in here and share your thoughts on the statistics?
Yeah, Vaishak, I think we have been in a lot of conversations where our end users are telling us the importance of lower latency and real-time responsiveness, leading to their demands or their desire to be a real-time enterprise. Because with so much happening in geopolitics, so much happening in supply chain disruptions, enterprises have to strive to become real-time in order to cater to customer demands. So I think that very much resonates. Thank you very much for summing this up. What's next? What more are we hearing 2025?
Yeah, thanks, Vaishak and Narayan sir. So to truly, as you rightly pointed out during the start of the webinar, ChatGPT was the earliest version of ChatGPT was launched in 2022 November. To truly understand what happened in 2025 and where we are going in 2026, I think we have to look at the trajectory that got us here. So if you look back at pre-2022, we were really in the era of silos and fragmentation. IT, OT, engineering, technology operated independently. Data was locked in proprietary systems, creating those infamous islands of automation, where companies that wanted to apply enterprise-wide analytics found it virtually impossible. Then between 2022 and 2024, we kind of hit a convergence, I would say. The advent of generative AI forced everyone to realize that you can't run advanced models on fragmented data. The industry shifted towards creating a single data layer breaking down these silos to provide a contextualized foundation. I think that brings us to 2025. So this was the year of scaling towards real-time enterprise, I would say. We saw massive scaling of connected technology, but it also set the stage for a reality check. We realized that instant enterprise-wide integration is incredibly complex, and that complexity is exactly what we need to solve for next. And I think Ignatius had some more information on this area.
Slide, please. Thank you, Akash. 2025, we agree like there's been significant or more drastic changes than we expected in terms of industrial AI, and things are moving forward pretty quick. So I would like to have an overall insight about what has actually happened and what is the reality check that we are going to that we analyzed during the 2025 year. So let me build on that. So the starting off with connected tech scaled. See, most industrial companies finally did their wiring right. More machines were connected, more sensors were connected, and every lines and more controllers became reachable right from the edge to the cloud. And we also see edge computing as well as edge-based deployments are started popping out for real-time processing as well. And we can also see that AI moved from just a lab-based systems to a more use case oriented or directly implemented at the industrial software suite level. So this has drastically changed how we perceive an industrial software market. So that is what we are observing in this current stage. Once connectivity and edge were in place, business leaders and naturally raised the bar. Why can't we do more about it? So if everything is connected, why can't we see the truth in the real time? That's when the real-time enterprises came into the market for real-time business evaluation and needed the insights right at the edge level. And based on this, we also have formulated the IT/OT data convergence, where we could find many vendors are mixing and collaborating with other vendors. It could be ABB or PTC's ThingsWorks, so on and so forth. And they are more narrow it down, having a more rethink on what they're actually doing in the marketplace with piece of integration. It feels like when the hype really meets the execution gap, it's a reality check. The integration part lagged behind because many of the industries here lacked with the legacy-based solutions. And it's like running like whole TV with cables running here and there. And we could see like whether it could be ERP or MES or SCADA or historians. Platform sprawl became real. One stack for analytics, or you could see one stack for device management and one stack for AV. And security became the prominent driving factor that every industry needs to adopt. So overall, 2025, what's the given takeaway is that scaling tech is not as scaling intelligence. Both have drastic changes and both have drastic gaps as well. So that doesn't mean that in the year 2025, we didn't see a significant impact of AI. We actually found many useful AI implemented actual result-driven use cases that we'll be talking forth in the next slide. So next slide, please. So I've summed up some of the interesting use cases where industrial AI played a drastic role. To start off with, many of the companies or process or discrete-oriented companies picked predictive maintenance as their test scale or pilot subjects to actually implement AI. And guess what? The results were actually driven in terms of ROI and also cost, and the failure was drastically reduced. That is what some of the drastic implementations of AI that took place. And then we have the edge-based vision systems where it used for quality inspections or in terms of rendering 3D images, or it could be any vision-based system where edge cameras as well as AI is directly implemented at the edge level, and it drastically increased their operation times as well. With we could find many use cases with like NVIDIA's GPU being used to run the render images, or vision-based systems are actually built on NVIDIA-based hardware as well. And then moving forward, we find sustainability is no longer associated in terms of data, but it is more in terms of industrial level or a software level. So each is focused and it's driven, and each is measured in terms of how much carbon you use, how much energy you use, and everything is calculated and formulated. That's when AI picture brings up the collaboration between the IT and the OT to drastically improve the operations at the shop floor. And finally, we've seen many R&D experiences that have been conducted on AI and leveraging more MI models that are more verticalized for real-time enterprise concepts as well. Team, I would like to hear your feedback as well on this one.
Thanks, Danny. I think we all have been part of briefings and conversations. So most of the use cases where success has happened, predictive maintenance, as you rightly pointed out, has turned out to be the most sought after use case where AI has been used, maybe because ROI is pretty easy to formulate there. And we talked about the role of edge, real-time enterprise, and now AI graduating into mainstream. So I think there are very clear-cut indications as to how things are looking in 2025, and then based on that, how are the ecosystem shifts taking place. So let's move on to the next slide. But before we kind of get into the exact ecosystems, let's also talk about some of the hurdles and gaps and how, what we saw, how they were overcome. And maybe, Vaishak, if you can throw some light here.
Yeah, sure, Narayan. So I will try to cover, what were the key hurdles manufacturers faced when during the digital transformation initiatives. And later, I would also share what are the key lessons we could share with you based on those reviews. So when we look back at 2025, the interesting thing is this: almost every manufacturer had a strong digital vision. But once we really got into the implementations and the use cases, the reality looked very different. And that gap between vision and execution became the defining theme of the year. So I will start with the number one key hurdle, integration bottleneck. So most organizations were connected but not integrated. So everyone talked about building a unified namespace, but very few operationalized it. So I'll just share you an incident. So there was this one manufacturer who shared an incident when their furnace was running below the target temperature, but the maintenance never saw the alert because quality, SCADA, and MES were three separate systems that simply did not talk to each other as it was supposed to be. So the lack of a unified data architecture became a major barrier to scaling AI. Now, the second hurdle is a platform sprawl. So we came across some deployments where the teams had so many point solutions, like let's say one for connectivity, one for data management, one for visualization, but nothing really talked to each other. So this is where many organizations felt the real cost of closed platforms. Now the third hurdle, and maybe the most overlooked of them all, is skills and organizational gaps. So we repeatedly heard the same versions from almost every manufacturers we have reviewed. So they say our OT teams knows the machines, but not the data. Our IT team knows the data, but not the machines. So this lack of combined fluency made it very hard to scale AI in industrial settings. So basically, you can have the best models in the world, but if your operators and engineers are not comfortable using them, nothing really moves beyond pilot. And finally, security. Now with more devices and more connectivity, OT networks becomes more easier targets. And in 2025, we actually, we are actively doing a research where we have found out that the number of, cybersecurity attacks on manufacturers, as I mentioned previously, there has been a steep increase in those incidents. And we'll be covering more about that in the coming slides. So when we put it all together, integration bottlenecks, platform sprawl, skill gaps, and rising security threats. So basically, 2025 showed us that technology was not the limitation, execution was. And that set the stage for what must fundamentally evolve in 2026. Anish, can you please move to the next slide? Yeah. So now that being said, what are the lessons we can, we would like to share with you based on these, reviews? So the first lesson is that architecture matters more than any individual use cases. So, whether it was a unified namespace or an enterprise data hub, the principle was the same. Create one consistent real-time view of operations. And these are the kind of architectural discipline that actually makes industrial AI scaling possible. Now, the second lesson was a mindset shift. Focus on outcomes, not hype. So the most successful implementations we have seen did not roll out AI just for the sake of AI. They used very specific KPIs and to decide where to invest. And the third lesson was that transformation is not just a technology project. It's a people and process project. So the plans that scaled AI invested heavily in operator training and IoT collaboration. And the final lesson was about resilience. 2025 made it painfully clear that security cannot be added later. It needs to be a top priority. So the big takeaway is this: 2025 did not just show us the gaps; it kind of showed us the playbook of unified architecture, outcome-driven investments, empowered people, and building resilience. So this became the patterns behind every successful industrial AI deployment, and I think they will define what must evolve in 2026. Team, feel free to add your thoughts here.
Thanks, Vaishak. I think some of the points you mentioned, like the people and process, mostly tend to get overlooked. And I can vouch with some of the conversations and observations I had with some vendors, where for implementations, they had created a team which was called as organizational change management. As advisors when they're implementing MES or PLM projects, because they needed that organization change management to happen before actually implementing those projects. So we have seen vendors making that particular course correction. Okay, now let's get into how the industrial ecosystem is shifting from data silos to uniform data layer, the convergence, the verticalization of industrial AI, and what is the end user opportunity and strategic mandate that we see as a result of these shifts. So who wants to jump in first?
I think I'll take this one. So I think you guys must have heard enough of the reality check so far, but that reality check has forced a strategic pivot in how industrial software architectures are developed. I think up until 2024 and even in 2025, we felt the friction of stitching silos. We saw a patchwork approach, especially when I talked to engineers from end user organizations. I learned that they spent more time building custom connectors between ERP and MES and SCADA rather than working on projects that deliver value. So I realized that they had kind of hit a wall because point-to-point integration doesn't scale at the rate of AI is scaling. So I think we are entering a future now which is about unifying the ecosystem, right? And we're moving towards a unified data fabric instead of the spaghetti mess of wires. You can imagine a circular integrated ecosystem where data flows freely between IT, OT, and ET layers. So this acts like a single source of truth, enabling instantaneous visibility. And I think this will set the stage for a massive ecosystem shift and the different types of partnerships that we are seeing in 2025 and we're expecting in 2026. Anish, if you can move to the next slide. Yeah, so why am I saying all this? So this brings us to the new industrial ecosystem. We're seeing the convergence of three critical domains: IT, information technology, or the business layer; OT, operations technology, or the production layer; and the critical missing piece, ET, or engineering technology. Historically, these three things have been completely siloed. So you can be an organization and your design team works in CAD and PLM, your operators work in SCADA and MES, and your business leaders go through the entire operations of business using an ERP software. But all these three groups of people rarely speak the same language. This is where we believe that digital thread is going to be the game changer. The massive shift in 2026 is closing the loop between engineering technology and operational technology. So this is what we call the digital thread opportunity. And I think it means that production data flows back into design to improve future products. And conversely, operators on the shop floor can access 3D engineering models and instantly pinpoint issues in the production line. I think the role of the digital twin, if you look at the center of the slide, this is where the digital twin lives, and it's no longer just a visual 3D model. I think it's going to be the intersection of these three different worlds, bringing them together. But to make this work, we need unified data models, and we need a unified namespace, that can handle sensor tags right from the shop floor, and also be able to handle complex engineering bill of materials simultaneously. And I think what it's going to have, I think it's going to force an organizational change. I think the silos will break down, and digital twin will merge IT, OT, and ET into a single live operational model based that works and abides by the laws of physics. And I think it will allow us as industry analysts and end users, and more importantly, the people who make the software, from simply running the plant to be able to optimize the plant in its original and intended form. Yeah.
I think Akash well said, because if industrial AI has to see the value, as we'll keep on talking in the next slides, I think this convergence has to happen, which has been happening. But I think if this convergence is not there, then again we have a weak data foundation. That means a weak, AI that is a result of that. So I think this convergence is one of the very important shifts that is going to happen. Yeah.
Thank you, Akash and Narayan. I think, Akash, I would like to take a point when you mentioned it was really interesting to see digital twins are more moving towards more physics-based systems that are, so they could be a process-based twins and discrete-based twins for different industries. That's a nice point to note down. And as you mentioned, the ecosystem shift will not only be for an vendor specific. If vendors are forced to change, so does its ecosystem as well as its partnership. So I would like to talk more about this ecosystem shift from a vendor perspective as well as an end user perspective. So I'm going to start off with from a vendor perspective. So we're going to take a step back and understand who is going to play this major role in this industrial software market. If you could see on the left, you will see a split between horizontal platforms as well as vertical specialists. Think of an horizontal players like your hyperscalers. It could be a Google or AWS, and more towards scaling towards having these data centers and running mostly on the clouds, and where it's formulated by highways with scalable platforms that handle connectivity and storage and generic analytics. Then we have the specialized vendors who could be either focused on single analytics or data contextualization like Cognet or SiteMachine, so on and so forth, all the UNS providers as well. And then you could narrow it down to more UNS sized vendors or edge-based vendors like Litmus, who are playing a significant role in the year 2025. We have seen major shift in their ecosystem as well. So now what we observe is a deeper alliance that we could see in this particular market space. Whether you could take ABB, their GenX platform, as well as the industrial copilots, is based off the partnership of Microsoft to help them build that analytical engine. So there's a super team building up in the industrial space, where we could see many are partnering with the ecosystem. This actually makes the ecosystem much stronger, and it's preventing more vendors to actually collaborate and build solutions that are both business resilient and operations driven, with pure intentions of making the outcome successful. So if you move to the bottom corner, then we find the outcome-based offerings are make significance, where it's tied to the portion of the revenue to uptime or energy or scrap reduction. In the process of having a broader SaaS players or an AI markets, where pricing seems to be linked with the successful resolutions or KPI improvements that are being directly impacted by the vendors in this particular landscape. Because as AI played a significant role, it also puts the vendors in the tight spot where they have to hold accountable or responsible for the results that they drive with their solution. So this space becomes more a cooperative landscape, where vendors compete and cooperate with each other with openness and integration, and are becoming non-negotiable standards, and then buying into the ecosystem, not a single product, as more like an ecosystem building. So moving on to the next slide, we'll be taking the information from an end user perspective, what end users can benefit out of it. So starting, as I earlier mentioned, there's vertical specialized players and horizontal specialized players who are most likely collaborating with each other, and their partner with network provider infrastructure players who handle all their networking. So this is more like a collaborative, where we can find the best of breed of technology to use for your solutions, where you can mix and match, play with it, and make sure it aligns perfectly with your vision. So you have plenty of options to choose from, but be careful because the complexity and the partnership can actually make your integrations life very hard. So that's another takeaway for the end user. And if you focus on the middle slide where we have 5 pillars to success, so which your focus should be on how to build your perfect ecosystem if you are a vendors for end user in terms of end user space. So first is like demand for openness, which means open standards or APIs or protocols or MQTT, whatever it is that you're using. They should be built for openness and focuses on outcome on every project that can be tied back to a KPI owned, whether it could be an OE or it could be a downtime or it could be energy, so on and so forth. And build an architecture for your flexibility that helps you to build a unified namespace where data flows from IT, OT, ET, all parts of the thing into a direct unified solution. And most importantly, don't forget to update your skills or your resources or your people. So that adds a significant impact in how well you're going to build a solution or how well they're going to utilize the solution. And moving forward, design for security, where security has been a top priority this year, and it also actually pushes the vendors into ecosystem of building a more resilient product. So this is not more about a hype, but it's about how you execute your solution. So build a resilient solution and then try to how to execute in your particular landscape. So the end users must have an idea how, even though if you want to build a solution, build it in the basis of your requirement and execute it with the requirement that offers you a return on investment as well as a cost benefit. Team, I would like to take your input on this as well.
Yeah, Danny, thanks. I think one of the most important things that is kind of to re-emphasize is AI starts becoming more and more impactful, as its scopes narrows down. The more narrow the its scope, it is able to give out more benefits and more impact. And therefore, it's no wonder that we are going to see vertically specialized, companies, trying to use AI more efficiently rather than companies which are, spread thin. So that is one of the main key, ecosystem shift that we are going to see more often as we go forward. Okay, next slide, please. So with these, with what we have seen in 2025 and the major ecosystem shifts, what are the strategic priorities that end users should look to? Mainly end users, but that does not mean that there are no strategic priorities that vendors or system integrators should also consider. So starting right from open standards to interoperability to context-driven business outcomes. Again, the point coming up is skills and security. So recurring themes, and there are strategic priorities that end users must kind of adopt to. So let's deep dive into those strategic priorities. Who wants to go in first?
Yes, Narayan. So I think I will take the slides. So till now we have covered what are the key hurdles manufacturers has faced, what are the lessons we could learn from that, and the team just talked about the ecosystem shift that's happening in the market. So now I will try to cover the strategic priority. So this is basically what we think manufacturers should prioritize going into 2026. So the number one thing, I think number one priority should be open standards and interoperability. So all through 2025, manufacturers told the same story. We bought great platforms, but none of them could really talk to each other. So this frustration is what pushed the industry away from closed and proprietary platforms. We basically saw a plan where pulling camera quality data into MES used to take 2 weeks of custom integration. But once they moved into an open API layer, it took them 20 minutes. So companies are finally starting to realize that closed systems actually slow innovations and makes integration even more harder. The organization that made the most progress also adopted a vendor agnostic mindset. So they wanted the freedom to choose the best component for each job, be it the best connectivity platform, the best platform for data management, without really being trapped in a single ecosystem. So there was this one manufacturer who was running Siemens PLCs, an Advantech gateway, and an AWS Edge runtime, and everything worked smoothly because the architecture was standard based. So standards based integration is going to become the backbone of the modern industrial data architecture. The third one I would like to highlight is industry consortia and common models, because we also saw a rise in these reference models, basically groups working together on a shared semantic and shared data structures and interoperable frameworks. Then, of course, you have the need for better integration tooling. So because instead of spending months on custom integrations, teams could finally start using reusable connectors, low-code integration layers, and middlewares that makes interoperability almost invisible. Now, the fourth one is, there's one more benefit to openness, which is it directly makes vendors accountable. For example, if a component is not really giving you a value, you can replace it without redesigning your entire architecture. And that actually keeps the long-term cost and risk under control. So the bottom line is that by 2026, open first architectures are not just preferred, but they are going to become the industry default. So the next major priority is moving from just, Anish, can you please go to the next slide? Yeah. So the next slide is the second priority I would like to highlight is the need for a context-driven business outcomes. So what we're seeing is that the plans are moving not beyond collecting data to actually generating business outcomes, and the missing piece here has always been the context. So first, fill the outcome gap. So most organizations in 2025 had plenty of data, but very few actionable outcomes. I mean, raw sensor values means very little without business context, like what product is running, which shift, what recipe, and what machine state. The second is semantic context as the foundation. So this typically means implementing a unified namespace or a domain-aware data model that standardizes key metrics across all systems. Because when every system speaks the same language, insights becomes more accurate and scalable. And the third is contextualization-driven AI. So AI does not drive on raw data. It thrives on clean, contextual, and labeled data. So you cannot just bolt AI on top of bad or uncontextualized data and then expect improvement in OEE, downtime, or energy KPIs. So the biggest value unlock we have seen comes from investing in contextual data modeling first. Fourth one is, of course, with context, KPIs becomes dynamic and more adaptive. So now instead of a static thresholds, you get intelligent targets based on product needs or let's say raw material quality or batch variation. So that takeaway is simple. You cannot improve what you do not understand. So contextualization is the bridge that connects raw sensor data to real business outcomes. And I think going forward, this is going to be one of the biggest competitive differentiators. Anish, can you please go to the next slide? Yeah, and finally, I would like to emphasize another very important priority manufacturers should keep in mind when they're adopting a digital transformation initiative, which is empower your people and bridge the skills gap. Because even with the best architecture and data models, industrial AI goes nowhere without people. So I think 2026 is going to be the year where I think workforce capability is going to be a top 3 investment area. So first, invest in your workforce. So organizations that scaled successfully, invested heavily in upskilling their operators, engineers, IT teams, and maintenance staff. So there was this one incident where an operator shared that once he learned how to read an FFT vibration chart, he could just spot bearing failures 3 days easily than before. So that is the power of upskilling, right? And that second is change management and adoption. So change management turned out to be the hardest part. So the most successful teams brought operators into the design phase early. So they made them familiar with the new dashboards and alerts, and they updated the workflow so that AI insights could actually fit into the day-to-day shop floor operations. Now, the third one is the need for stronger IT-OT collaboration. So I think we are going to see that the cross-functional teams are going to be non-negotiable. And the fourth one is, basically hiring and partnering strategically. So we are going to see more demand for roles such as data engineers, OT architects, and AI ops specialists. So the real lesson is this: industrial AI does not scale because the technology matures. It scales because the workforce does. Team, you want to share your thoughts on this?
Yeah, Vaishak, I think some of the things you brought about, like the first one was in terms of open systems, interoperability, and industry consortia. What best example can we cite than what ExxonMobil is trying to do with open process systems or open automation systems, even at level 0, level 1, and level 2, where we have the conventional instruments, the field controls, the supervisory controls, which is very, very proprietary or used to be very, very proprietary. They are now pioneering open systems, plug and play systems, where the control logic moves away from hardware, goes into the software layer, so that we have more compatibility between different vendors, and vendor lock-in is avoided. So we are seeing a lot of movement there, and will continue to happen. The second point that you mentioned was about context. So as we just talked earlier, the more depth we give to AI, the more use specific it becomes, the more deep it goes into our industry vertical. That means we are giving it more context, and more context rich data, I think more better AI is going to help us. And other thing, very important point you mentioned about people and the talent. So I remember a recent conversation with one of the executive search companies, who hire executives at CXO level, all the CEOs, CTOs. So they are now going beyond leadership skills and core technical skills into what is being termed as AI fluency. Like, how fluent are you in adoption of AI? And that has to start right from the top, and then go right up to operators, as you said, the people on front line who matter the most in order to succeed in what industrial AI is going to bring to you. I think moving on to the next slide. One thing which was like whatever you do, if you don't have a very good cybersecurity foundation, then this will be a big catastrophe. So having a very good architecture for your security, that is compliance with industry standards, with zero trust architecture in mind, is going to be very, very important. And that architecture has to be very resilient. It has to take into consideration typical requirements of OT, because with OT you have hundreds of endpoints. Suddenly your exposure, your attack surface increases. So all that has to be taken into consideration when you're talking about the resilience in architecture. Then you have to continuously monitor the threat landscape, the vulnerability, the exposures that you are going to get, and take corrective, preventive actions as required. And then it's not only security, at times you also have to consider the safety of your plant operations, of your people. That is also very important. So by treating security and resilience as foundational, I think we can then drive more sustainable and reliable digital transformation, which will ultimately lead to the industrial AI, which can really deliver value. Let's move to the next slide. Okay, now just to state like how important the security portion is, we have seen, based on QK's research, our market intelligence, and other sources, that manufacturing has been targeted time and again for ransomware. In Q3 2025 alone, we saw 184 confirmed attacks. And overall, from 2024 to 2025, there has been a 61% rise in ransomware attacks. So whatever you are doing in order to derive value, the convergent systems derive value from AI, without cybersecurity, proper cybersecurity measures, it's going to be very, very vulnerable. You would recall one of the recent the incidents that happened at Jaguar Land Rover, where just from August 2025 end till October, we had weeks of shutdown at their various plants, in UK, China, Slovakia, India, Brazil. Significant financial losses, significant loss of reputation. And this is not only incident. There have been a lot of such ransomware attacks on core manufacturing, water utilities, and energy utilities. I think this underscores the importance of very good security infrastructure when you are driving, when you're trying to create value from your industrial AI. Moving on. Okay, I think we now come to the most exciting part, and I'm sure the audience is also, going to be very excited about what's in store. What do we feel as analysts, what's going to happen in 2026? So, ready for the predictions? Who is going to start the first prediction?
Yeah, I think I will start this section. So we have been hearing about industrial AI a lot. So we assume that now industrial AI is going to be more mature, and in 2026, we think it's going to become more ubiquitous. So as we look ahead to 2026, one clear pattern is emerging from our conversations with both manufacturers as well as vendors. AI is moving from isolated pilots into the actual operational fabric. And three major shifts will be defining this transition. Number one, pervasive intelligence. So first, intelligence becomes pervasive. So I think AI will no longer sit as an add-on layer. It's going to become a default feature of industrial systems. And we are going to see more lightweight machine learning models running directly on PLCs, cameras, and edge devices, while large-scale GenAI reasoning stays in the cloud. So industrial AI will simply process data that it makes the most sense, edge for speed and cloud for depth. Now the second is the rise of industrial copilots. We believe that AI is going to shift from passive analysis to an active copilot. Agentic AI will work alongside humans, querying manuals, checking inventory, and even drafting work orders autonomously. So AI is going to turn from just a reporting tool into a day-to-day operational partner. Third is generative interfaces. We think that interfaces are becoming more conversational. For example, an operator can just ask, simple questions, natural language questions like, why is line 3 running slow? And they can receive synthesized and context-rich answers. So overall, 2026 is the year AI stops being a feature you bolt on, and it's going to become a core part of how operations think, respond, and optimize in real time. So what about the other predictions, team?
I think I'm going to one up you with my prediction. I think my prediction is that digital twins will evolve to drive proactive operations. For a long time, twins were just visual representations. I think in 2026, they become the context engine of the enterprise. They will serve as a living semantic model that instantly contextualizes raw IoT data into business logic. For example, till 2024, in a factory or in a oven, a temperature reading of 400 degrees meant exactly what it is, temperature reading of 400 degrees. But with the advent of twins, numbers have gained something that they didn't have before. I think the numbers have gained context. The twin tells you the context behind the number 400. So if you see a 400-degree rating, it would mean the twin would tell you oven 4 or reactor 4 is overheating during a critical cycle in the process. I think this context allows engineers and plant operators alike, to move the situation from monitoring to simulation. So operations teams can run what if scenarios on the twin before making real world changes. It's like simulating a new production schedule to ensure that the process goes on smoothly and it does not violate any peak power energy constraints. And it might not even be twins associated with single assets. It could be for entire systems. I think that is going to result in a holistic optimization, especially in areas that, as I suggested, like a production line or a supply chain. And I think it will help in creating a sustainable future by balancing energy, throughput, maintenance, all things simultaneously. I think I'll take the next prediction also. Anish, can you move to the so my next prediction is about event-driven automation and autonomy. So I think I predict a move towards event-driven automation and autonomy. We are effectively seeing the death of polling. The era of asking a machine how are you every 15 minutes is over. We are shifting to a publish or subscribe architecture where machine publish events in real time. This enables what we call automated feedback loops. So you can imagine a vision system detecting a defect. In a real world situation, in a factory, the conveyor rejects the part, the MES logs the scrap, the machine adjusts the parameters to prevent the defect from happening again. And all of this happens in milliseconds without human intervention. I think this is the technical backbone, that will allow humans to create islands of autonomy. I think this will help people operate large assets without human oversight, and these assets can self-optimize based on real-time data. And I have an interesting tidbit about China here. As we all know, China runs a lot of these dark factories which are able to run 24/7, and they use these dark factories to build ships without human intervention. They are building battery technology, facilitating expansion of electric car production. I think this technology is in the brink of explosion in 2026, and I think this is one of the core reasons why China is increasingly becoming the biggest naval power known to mankind.
I'll be taking the next prediction. So my prediction is that unified edge to cloud orchestration, where we find a significant data transformation between IT and OT, as well as the ET layers. So I think unified edge to cloud will help to formulate a more unified solution where data flows freely from the edge to the cloud and everything comes under one roof. So in today's world, we might see like data is clustered in one location and AI runs, the workload is running in other. So my point is that to treat a single pane of glass or one pane of glass where a unified data is treated, as well as data flows on top of everything so that it's easily manageable, whether it could be a single asset or a multiple assets as well. And make sure you prioritize a workload portability, whether it could be a cloud or an edge. So the models have been running from edge to cloud, keep the data where it's meant to be. So the right data at the right place at the right time, whether it's on premise or on edge or on cloud. So create a workflow portability so that the data can be synthesized properly and used at a proper location with with proper uses of cases, so that it is. And the other thing is could be backed up with a network as an enabler, where a network rolled out, whether it could be a private 5G or it could be an other base network IT connectivity management players on the market. So it could have a significant impact that allowing edge and the cloud to seamlessly interact, and the transfer data is more orchestrated in a correct manner. So moving on to the next prediction.
Okay, I think I'll chip in with some of my contributions, some of my predictions. So as we saw, the bar has been raised in 2025, and it has been raised that only the production grade survives. And so it has to meet enterprise benchmarks, the software platforms that are going to evolve. So the pilot phase is over, and buyers are ruthlessly wanting to go and looking for enterprise readiness. So no longer softwares can afford to bolt in different connectivity. There will be some default connectivity which is already native with drivers for connectivity. Then security by design, again, totally non-negotiable, zero trust, SOC 2 compliances, and systems that can scale even to handle million plus tags without significant latency. Then we are going to see that openness is non-negotiable, like vendor lock-ins are strictly no, and what like for example, it must be easily able to export to data lakes or import third-party AI models in terms so that it becomes an open system. And as we talked about earlier, we are going to see the rise of the vertical specialist, because AI really thrives, in specialized and context-rich environments. So we are going to see that, vertical platforms sitting on top of horizontal infrastructure. You don't have to now build systems right from the scratch. Lot of pre-configured systems, because as you narrow down the scope in terms of use case and context, it is easy to pre-configure systems. So we are going to see more of that. And of course, we are going to see it sitting on pre-built data models. So industrial buyers will begin to demand holistic capability as we go forward. So to conclude, since I think we're kind of running out of time, let's go to the next slide, the final slide. What are the guiding principles for 2026 and beyond? So what is the North Star that you should look at? And it's simple. You should look for value over hype. Those you have to turn the architectural shifts into your competitive advantage. Don't have to look technology for sake of technology, resist the shiny object syndrome, and just focus on the context that the technology creates. If your pilots or experiments are not yielding results, it's good to fail, but kind of make that cycle pretty fast so that you have a clear path to production scale systems that you do in less than 6 months, and prioritize durable transformation over just experimentation. Okay, so once you have value as your North Star, then what is the strategy going there? As we discussed, it's the convergence has to by design. No silos of IT, OT, sustainability, ET, the drive towards real-time enterprise because of the convergence, and cross-functional digital operations team to manage the entire data lifecycle, because data is the backbone on which AI resides. Then from strategy, how you move to execution is, you fix the context, before AI. You challenge your vendors, demand openness and data exit strategies. And most importantly, we are saying empower your people, mostly the frontline workers who are really the ones who are actually in the thick of action. So, and then from execution, then we move to the destination of intelligent autonomous operations, as we have been talking about, to move from connected assets to self-optimizing systems, and then invest in context, openness, people, which are the foundation for tomorrow's autonomous plants. Thank you very much. I think that is all we have. We kind of slightly exceeded the time, but I hope you all found this, this particular contents to your liking, and we hope to get your feedback. We are also open to Q&A. You can put any of your questions, and we are happy to answer them.
Thank you, Narayan sir. Thank you, team. Thank you for sharing your insights and walking us through 2025. And I'm sure our manufacturing leaders are more prepared to tackle 2026 and for the year ahead. We have received ample amount of questions already, team, and I doubt whether we can answer all of these. But I have shortlisted a question from what has been raised by the audience. So the question is to you, the team. So in your initial slide, you had mentioned that 2025 was a reality check where many digital pilots stalled. And if technology like AI and IoT is ready, what is actually stopping, or what is actually this bottleneck stopping these projects from scaling?
Akash, you want to take it?
Yeah, that's interesting. I'll take this one. See, that's a great question to whoever asked. The bottleneck usually is not the technology itself, but as we have been preaching today, it's the architecture underneath it. You see, in 2025, many companies tried to bolt on AI to legacy systems that were not inherently designed to share data. So what they do is that they put AI first procurement, AI first supply chain, AI first supply chain planning software. But then they spend 80% of their time building custom connectors and what we call internally integration hell, and ending in, by following the Pareto rule, 80% of their time they spend building custom connectors, and only 20% of the time analyzing the value and realizing the value out of this. I think the reality check here is that these people should realize that you cannot scale intelligent operations on a fragmented foundation. To fix this, companies should opt what we call the unified namespace or a single data layer, so that when you do deploy AI, the data is already clean, contextualized, and it's ready to use. I think that's what we call the bottleneck here. That's what we call the reality check here.
Thanks for answering that, Akash. And once again, to all those who have raised your questions, we'll surely answer those questions via mail. We'll reply back to your questions via mail. And once again, thank you all for joining us, for sparing your last 70 to 80 minutes. To all those who joined us early in the morning, and to all those who joined us later this night. Once again, thank you for joining us, and do follow us on LinkedIn so that you can stay updated to our upcoming webinars that is going to happen. And thank you guys. Thank you team for sharing your insights. Until next.
Thank you.
Thank you.
Thank you.